Welcome to Brain Vision.
To solve this question, I will choose the following reference frame. The vertical axis, which is the y-axis, will be pointing up, and the horizontal axis, which I will call the x-axis, will be pointing to the right. Then we use Newton's second law to calculate what is the acceleration of the airplane. Notice that the airplane moves on the horizontal axis, so we should apply Newton's second law on that axis to discover its acceleration. By doing that, we get the following. So, applying Newton's second law to the plane, specifically to the x-axis, we get that the net force in the x direction is equal to the mass of the airplane times the acceleration of the airplane in that direction. The net force in that direction is composed only by one force, the tension force. Therefore, the tension force is equal to the mass of the airplane times its acceleration. Then, the acceleration of the airplane is equal to the tension divided by its mass. Why have I done that? Because of the following. We want to know what is the maximum possible acceleration for the airplane. Then, we know now that the acceleration is proportional to the tension. Notice that we can't really change the mass of the airplane, so the only thing we can change is the tension force. So now our objective is to find what is the maximum tension force, because the maximum tension force will result in the maximum acceleration. So now how can we determine the maximum tension force? To do that, we have to look now at the man that is trying to pull the airplane. Specifically, we should apply Newton's second law to the man. But now as the airplane is moving on the horizontal axis, let us apply Newton's second law on the man on the horizontal axis first. So now we are applying Newton's second law to the man. On the x-axis, it results in the following. The net force in the x-axis is equal to the mass of the man times his acceleration in the x direction. But the net force in the x direction is composed by two forces, the tension force and the frictional force. Notice that the tension force that is acting on the man points to the left, then it has a minus sign, while the frictional force points to the right, so it has a positive sign. Then the frictional force minus the tension force is the mass of the man times his acceleration in the x direction. Now note the following. The acceleration of the man is the same as the acceleration of the airplane. This is because we are supposing that the cable that is being used is an ideal cable. It means that it can't be stretched or contracted. Then we can equate the acceleration of the airplane with the acceleration of the man to get the following. The frictional force minus the tension force is the mass of the man times his acceleration, which is the tension force divided by the mass of the airplane. Then we can send this tension force to the other side to get frictional force is equal to the tension force plus the mass of the man divided by the mass of the plane times the tension force. We can then factor the tension force on the right hand side to get tension force times 1 plus mass of the man divided by mass of the airplane is equal to the frictional force. Then we can solve for the tension force to get that the tension force is the frictional force divided by 1 plus the mass of the man divided by the mass of the airplane. And now we can conclude the following. The maximum tension happens when the frictional force is also the maximum frictional force. And we know that the maximum frictional force in this setup where the frictional force is static is given by the static frictional coefficient times the normal force that acts on the man, because the frictional force is acting on the man. Then this is divided by 1 plus the mass of the man divided by the mass of the airplane. Let me organize the board to continue solving this question. Now the only thing that is left for us to discover is the magnitude of the normal force that acts on the man. But this is very easy to do, because you see that the normal force acts on the vertical axis, and the normal force that acts on the man is being counterbalanced by the weight force that acts on the man. So as the man isn't going to fly away nor going to fall below the floor, the only conclusion that is possible is that the normal force has the same magnitude as the weight force. Then the tension force can be written as frictional coefficient times the weight force that acts on the man, which is the mass of the man times the acceleration of gravity, divided by 1 plus the mass of the man divided by the mass of the airplane. Now we plug in the values that were given in the problem, remembering that the acceleration of gravity is approximately 9.8 meters per second squared. Then the maximum possible tension force is given by 0.77 times 85 times 9.8 divided by 1 plus 85 divided by 109 3 zeros, and this gives us a tension force of approximately 640.9 newtons. Now we can go back to the equation for the acceleration of the plane, which is this one, and calculate the maximum possible acceleration. So the acceleration on the x-axis of the plane is equals to 640.9 divided by the mass of the airplane. And this results in an acceleration of approximately 0.0059 meters per second squared, which we can write as 5.9 times 10 to the minus 3 meters per second squared.